I'm Philip Bell, developer advocate with Meta. I'm going to talk to you about the past, present, and future of Presto. So over the last few years, the Presto community involvement has grown, and we've accomplished some major architectural improvements. Achieving this required successful refactoring of Presto's industry-leading speed, efficiency, reliability, and extensibility, empowering the Presto community to be able to benefit from and evolve Presto for the years to come beyond what Meta could achieve has required significant investment of time and resources. I'd like to quickly review what we've accomplished as a community recently and share what we're hoping to evolve Presto into in the coming future. So first of all, why should you continue to use Presto is you get a battle-tested tool that is used and supported by industry leaders and runs at meta scale. Here's just a few of the organizations we know are depending on Presto. And here are the major contributors ensuring Presto stays cutting edge. What do we mean specifically when we say meta scale? Within Meta, Presto is used by nearly half of all employees either directly or indirectly. And if you've been paying attention to the news, you kind of know exactly what that number is. We run Presto also across dozens of data centers with a node count exceeding double 50,000, and our exabyte scale queries are still interactive at speed. With all of this, the ingenuitive and passionate Presto team within Meta holds itself to a rigid set of SLAs to ensure our internal users never see an issue with performance or reliability. Over the last few years, we've pushed 56 releases, and as Tim already mentioned during his keynote this morning, the Presto open source community has been incredibly active and still growing. Last year, the community chose a list of areas to focus on through the end of 2022. So what does it look like working on those milestones over the last year? In the last year alone, we had 21 releases, 2,000 new stars, 600 new forks, 152 new contributors joined our community, 17 projects marked themselves as dependents, all working together to improve Presto across connectors, cloud support, language features, performance, reliability, security, transaction manager support, user experience, and writer enhancements. It takes a lot to make all of this possible, especially with the massive scale and complexity of Presto. To achieve success as an open source project, we found these paradigms to be crucial. Clear and explicit guidelines for how to collaborate, adhering to code quality standards, especially around readability and maintainability, mentorship of new contributors, having an open governance model, responsive and respectful community interaction, ensuring there is room to experiment, and a truly flexible design from the beginning. We would love to see each and every one of you in next year's Git history visualization. And together we made significant strides in all of the areas that we set about to accomplish in the last year. So I want to quickly touch on those contributions that would not have been possible without community-led efforts before we talk about the future. So connectors were enhanced and added, cloud support wasn't added, language features are crucial for a tool that promises to execute correct SQL against all sources, and significant strides were made there as well. We spent a lot of time on Presto's performance across many pieces of the architecture, and when you expect the kind of performance Presto delivers, every enhancement is highly impactful. Interactive queries means ensuring even long-running queries succeed, which previously were unsupported by Presto, which I'll discuss more shortly. And whenever you're dealing with federation around data, security is especially important. Growing table format support is important as we ensure Presto co-evolves with new and data store designs. We also take user feedback just as seriously as developer feedback, and are always looking for ways to improve the experience for users who may not even know that they depend on Presto within their workflows. Modern Presto now treats writes as important as reads. And as far as what's next, and what we hope that you will help us achieve, Tim mentioned some of these this morning. I'd like to go a little deeper with you all into those focuses that we've set for the next year. So let's start with the challenges we've observed recently. Many of you may recognize this data stack from your own architectures and organizations. You have Presto for dashboards, a real-time analytics. You may use a really powerful feature of Presto, which is spinning up a cluster to that is specifically optimized for batch reliability. This allows you to quickly experiment with a query as you would for ad hoc analytics, but historically you'd run into an issue. Eventually, something changes. It could be that a hash build no longer fits within broadcast limit. It could be that there is a significant data skew. The possibilities are exponential, but the one constant is that pipelines will change over time. Presto cannot know when this will happen, and therefore address the change internally. The result is often suboptimal for Presto's massively parallel processing architecture. Similarly, with interactive workflows, eventually a dedicated system that emphasizes data locality to run quickly is desired. Typically, data engineers look to merge compute and storage to reduce data transfer costs, and soon you need yet another pipeline to ingest data, another system to support and maintain, and provide SLOs for. If nothing changes, you end up with longer execution times and spilling. Increased duration is the common issue here. Presto and its users are happiest when everything completes quickly. But as things take more time, workflows break down. Presto's resource management is slot-based. We don't have resources as a service. Everything is allocated up front. To mitigate, you have two options: under-admit, which significantly increases your costs, or quickly migrate to other systems when failures arise. Both options are compromises with consequences. If you choose to under-admit, you leave money on the table and have to manage more underutilized clusters, which comes with a fixed cost overhead. If you choose to triage each failure, then your data engineers pay the price themselves in mental energy and falling morale. Important meetings, long-term projects are all put on hold and interrupted as the fastest growing data flows, which are usually your most crucial, screech to a halt. We live and work in big data. Do we ever settle for suboptimal? Do we stop when the limits are reached? Or do we find a way to engineer around the problem and build a better solution for the future? This is what we want to see everyone using Presto. Presto spanning interactive and long-running batch workloads. How are we accomplishing this at Meta specifically? With Presto on Spark, we completely avoid replatforming by leveraging the mature, battle-tested Spark distributed execution framework. There is a system that manages batch workloads that sits in front of the compute engines. Previously, it would simply fail, but I don't know what's going on. Is that better? All right, I'm just going to hold that. Anyways, yeah. So when resources reach a predefined level, they'll move to Presto on Spark. Unlike interactive queries, where things are not entirely known in advance, in batch, they're mostly known because each workload is tested initially, then repeated on a set interval. For interactive workflows, we target the queries that are likely to be caching aware and give them session properties to leverage the cache. We have sophisticated scheduling that will automatically leverage local SSDs to populate the cache, automating much of the optimization. Importantly, data engineer involvement is not needed, only the operator of Presto. Specifically, what are we doing to help make this a reality? We've cataloged all the discrepancies between Spark SQL and Presto on Spark and are working to methodically eliminate each of them. Depreciating our previous effort, LBM, and why would we depreciate it? Because it's redundant with what Spark does. When Presto is required to be run on a materialized exchange platform, we aim to converge on Spark as the clear, trusted platform of choice. Hardening Presto on Spark means continuing to make this platform a success, continue to make fixes, and continue to move some of the toughest workloads in the world onto the platform. One especially crucial piece for focus in the next year is the optimizer. Optimizations are key to Presto being algorithmically efficient. This is an area where there is a clear path for improvement. One of the top areas for improvement we're looking at is using historical statistics to improve execution. Simply put, we look for similar fragments that have executed in the past by putting these statistics into some kind of store. When a new query arrives for execution, we check to see if it's in the store. If we see a match, we can use the statistics to aid the optimizer and improve Presto's algorithmic efficiency even further. Some other ways are listed here, such as improving the join order, automatically using broadcast join, making optimizations for hash aggregation enablement, and setting the hash partition count to improve performance for smaller queries. In a similar vein, we want to work towards the ability to do optimizations adaptively. To be blunt, table statistics can be a crapshoot. Even with the previous optimizer, which we expect to have a massive impact for things such as dashboards and batch workloads, statistics can fluctuate instantly. We want to approach this differently. Be adaptively re-optimizing to take into account new, unexpected information. That's what adaptive query execution is. You saw this morning and what it looks like. We're moving away from a top-down optimizer into a continuous cycle of optimizers, each one feeding into the next with statistical information. By optimizing in this way, we can take into account sudden changes that other optimizers miss. Not unlike how Presto was originally designed as an MPP technology, we're bringing that same proven design to the optimization layer. So we've optimized for batch. What about improving interactive workloads? The original reason that Presto was created. Today, hardware is unlikely to be homogeneous, and on top of that, Presto uses resources in workers non-uniformly, which results in efficiency left on the table. Now, as data engineers, do we ever stop when there's efficiencies yet to be realized? Of course not. And we want Presto to automatically load balance its workload placement system by factoring in unused capacity in its workers. In the past, the coordinator would only receive heartbeat status from its workers and randomly assign work across whoever is available. Now, workers report back more detailed status, allowing the coordinator to drive even higher efficiency by selecting the best available worker for the task based on utilization. This year, Meta Open Source announced a major effort in improving worker nodes, not only in Presto, but across all of its internal data engines and storage systems. How many of you have heard of VLOX before today? A few, okay. So started at Meta, early tests of VLOX have shown 2 to 10x performance improvements for different use cases. We're working to integrate it into over a dozen internal systems. So certainly tell all of your C++ developer friends that we're looking for contributors, but let's talk about Presto specifically. Truly massive improvements in efficiency, latency, and performance are on the horizon. Improvements in optimizers and workers are not unlike upgrading RAM and switching from disks to SSDs, bringing throughput to new levels, but doing one without the other means you're not realizing the full potential of either. Many of the improvements we're working on fall in the category of algorithmic improvements. Have Presto plan to execute better algorithms? Here, there is also an aspect of algorithmic improvements at a lower layer within a fragment, taking advantage of local knowledge and data skew, making local optimizations that improve global performance. Presto currently uses a Java evaluation engine, so code that actually loads and processes the data itself is written in Java. Java is perfectly acceptable for most data-intensive applications bound by constraints typical in a corporate enterprise setting. But batch is measured by efficiency, and when garbage collection and poor memory management takes up around 20% of your resources, there's definitely room for improvement. VLOX itself is a C++ library for building evaluation engines that take into account best practices such as adaptive optimizations and vectorized execution right from the beginning. We want to replace Java Presto workers with VLOX-based worker nodes. In early performance tests, we find that most queries at the very least end up with running twice as fast, with a median landing around somewhere around 5x. So we see truly massive performance improvements, and this will open up Presto to more performance-sensitive use cases, such as heavy dashboards, online use cases, and ensure Presto continues to be the de facto choice for ad hoc analytics across the industry. The potential here for batch side is even more exciting. Moving Presto towards being a single platform with single semantics, we will radically improve the performance of batch queries by utilizing VLOX. This translates into faster batch queries that require less resources, which means less support and KTLO. Most of all, it means potentially creating significant reductions in costs and energy usage thanks to the super efficient evaluation of data-intensive queries that have smart local optimizations. Finally, we're focusing on the ability to run Presto on less stable hardware, such as Spot instances. You've been able to do this for a long time with large batch mode and Presto on Spark. However, now the focus is on the ability to do this for interactive workloads. The way that we're going to do this is to separate Presto's hardware into separate pools and treat each pool differently. As an example, certain pools have characteristics that make them easy for retry. The powerful thing about this is we can selectively run specific queries that can't take advantage of caching on Spot instances in order to run cheaper and to address demand. Suppose all Spot capacity is removed, then we can configure the pools to move to dedicated hardware that has flash support. The idea is to separate capabilities into multiple pools and allow the administrator to configure which workload is ideal for each pool. For large cluster support, Capacity pools in Presto Pack lead to improving how we scale Presto. Traditionally, we scale horizontally. If you need more performance, you stand up another cluster and throw a load balancer in front to direct traffic to the clusters. We've removed the traditional constraint from running large clusters through disaggregated coordinators. Now you can run several coordinators in a cluster and evenly distribute the load across all the coordinators. This also means a previous single point of failure is no longer an issue. Utilizing Presto on Presto Pack to evenly distribute the load, the fault tolerance and capacity pools to introduce flexibility in which capability queries. Anyways, we hope to create a smoother experience in regards to auto-scaling support and introduction of elastic capacity for workload it supports. This opens up options for introducing significantly more powerful, even custom hardware for queries that will support it, and deprecate the horizontal loading strategy to reduce the operational overhead of running your Presto clusters. We want you to help build the future of Presto. So as far as how you can contribute, I just quickly want to review. If there's missing documentation, oh my God. I think I got it. Nope, okay. If you see documentation missing, please file an issue. And if you're up for writing it yourself, we absolutely welcome it. GitHub issues is also the best way to communicate with Presto engineers in the greater community about what features you would like to see or challenges you're running into. If you see an issue you are familiar with or can help with, don't hesitate to jump in and share your knowledge and skills. We love hearing about how Presto is being used. A short tweet or a blog goes a long way towards helping other people learn about how Presto might help them solve their own data challenges. There's a quick review of various tools I use to create parts of this presentation. I'm not going to keep you from the social that the amazing Ahana and Presto Foundation team has set up, but do reach out to me over Twitter or Slack. I promise to respond to any and all questions and find the subject matter expert if it's beyond my own capability. Thanks for your time, and I really appreciate everyone showing up. It's really great to meet some of you.